Alright, let's do 13.61b. Calculate the mass of propylene glycol that must be added to water to reduce the vapor pressure by 2.88 torr at 40 degrees Celsius. Okay, so let's write down our given. What are we given? We're given a solution whose solute is propylene glycol. Solute is propylene glycol C3H8O2. If you do the calculation, the molar mass should be 76 grams per mole. 3 carbons, 8 hydrogens, 2 oxygens. 76 grams per mole. Our solvent is H2O. Of course, the molar mass is 18 grams per mole. What else are we given? We know that the mass of the solvent is 340 kilograms, so mass of H2O is equal to 0.340 kilograms, and in grams that would be 340. What else do we know? The temperature is 40 degrees Celsius, and at that temperature the vapor pressure of pure water is, if you look it up in Appendix B, it's 55.3. Appendix B again, 55.3 torr. This is in Appendix B. Okay, it says that we want the vapor pressure to decrease by 2.88 torr at 40 degrees. So therefore the P of the solution, the vapor pressure of the solution, is 55.3 torr. Vapor pressure of pure water minus the decrease, which is 2.88 torr. So that should be 52.42 torr. Okay, so those are our given. So what is required? Required is the mass of propylene glycol of C3H8O2 that will give this vapor pressure. The 52.42 torr. So we go back to the formula. The vapor pressure of a solution is equal to the mole fraction of the solvent times the vapor pressure of the pure solvent. We know the vapor pressure of the solution is 52.42. This is torr. We're solving for the mole fraction of the solvent, mole fraction of water, and the vapor pressure of pure water is 55.3 torr. So then the mole fraction is equal to 52.42 torr divided by 55.3 torr, and that would be 0.950, and there is no unit because numerator is torr and denominator is torr, so they cancel. Okay, so now that we know the mole fraction, what is mole fraction? Mole fraction is equal to mole fraction of the solvent, which is water, is equal to the moles of H2O over the total moles of the solution. Is moles of H2O plus moles of propylene glycol, C3H8O2. But what is moles? Moles is equal to mass over molar mass, isn't it? So then the formula for partial pressure mole fraction of H2O is equal to mass over molar mass of H2O over mass over molar mass H2O plus mass over molar mass of C3H8O2. Now that we have that, we can substitute the values. So the partial pressure is, not partial pressure, the mole fraction 0.950 is equal to mass of the water in grams is 340 grams. Molar mass of water is 18 grams per mole. All over, again, 340 grams over 18 grams per mole. Plus mass over molar mass of propylene glycol. So mass of propylene glycol is what we're looking for, C3H8O2, over the molar mass, which is 76. So what is, if you do this is just arithmetic, basic arithmetic. So if you do the algebraic hocus pocus, you should get the formula mass of ethylene glycol, C3H8O2, is equal to 340 over 18. Now, if you do the math, I'm running out of space, I'm sorry. But if you do the math, you solve for that mass of C3H8O2, you should get a mass of 75.6 grams.